State the condition for a distortion-less transmission line and comment about the same. If the attenuation constant alpha is 20 into 10 raised to minus 3 Newton per meter, velocity v is 1.8 into 10 raised to 8 meter per second, and Z0, that is characteristic impedance, is 60 ohm, then find out the primary line constant of such a distortion-less line at frequency f of 100 megahertz. So for distortion-less line, attenuation constant is given. For distortion-less line, attenuation constant is given by alpha is equal to square root of r into g. So alpha is 20, it is 20 into 10 raised to minus 3 square root of rg. Therefore rg is equal to 20 into 10 raised to minus 3 square. It is 1. Now characteristic impedance is given by Z0 is equal to square root of r by g. So it is 60 is equal to square root of r by g. Therefore r by g is equal to 60 square. This is equation 2. Next is multiply equation 1 and 2. Multiply equation 1 and 2. So rg into r by g is equal to 20 into 10 raised to minus 3 square into 60 square. So it is g get cancel, r square is equal to it is 400 into 10 raised to minus 6 into 3600. Therefore r is equal to 1.2 ohm. It is actually 1.44 and r is equal to 1.2 ohm. Now we have to find the value of g. So g is equal to, now we use equation r by g is equal to 60 square. Therefore g is equal to r divided by 60 square. Value of r is 1.2 divided by 60 square. So this 3.33 into 10 raised to minus 4. Now velocity of propagation. Velocity of propagation, it is given by v is equal to omega by beta 1.8 into 10 raised to 8, that is equal to omega is 2 pi f by beta. Therefore beta is equal to 2 pi f is 100 megahertz. So 100 mega is 10 raised to 6 divided by 1.8 into 10 raised to 8. So this value is 3.5. But we also have beta is equal to 1 by square root of LC. Therefore 1 by square root of LC is equal to 3.5. So 1 by LC is equal to 3.5 square. So LC is equal to 1 by 3.5 square. So we can write LC is equal to 0.0816. This is equation 3. Now for distortion-less line, L by C is equal to R by G. So it is 1.2 divided by 3.33 into 10 raised to minus 4. So L by C is equal to 60 square. This is equation 4. Now multiply equation 3 and 4. Multiply equation 3 and 4. Therefore LC into L by C is equal to 60 square into 0.0816. Therefore L square is equal to 293.76. So L is equal to 17.139 Henry. Now from equation 4 we can write L by C is equal to 60 square. So it is 17.139 by C is equal to 60 square. Therefore C is equal to 17.139 divided by 60 square, that is 4.76 into 10 raised to minus 3 farad. A transmission line of 10 km length has following parameter, that is Z0 500 angle 0 alpha is 0.1 Nm per kilometer, beta 0.04 radian per kilometer. Calculate the received voltage and current when 20 milliampere is applied at the sending end and receiving end is short circuited. So this is the case of finite length line short circuited at the load. We write here, this is the case of finite length line short circuited at load. When the line is short circuited, when line is short circuited, we have equation of voltage. We have the equation of voltage as ER is equal to 0, that is ES cos of gamma L minus sine. Therefore ES cos of is equal to I0 Z0 sine of, it is divided by cos of. Therefore ES is equal to IS, it is IS not I0, it is IS Z0 sine by cos is tan. This is equation 1. Now we have the equation of current at distance x. Equation of current at distance x from sending end is I is equal to IS cos now here x is equal to L is 10 km, which is given. Therefore I is equal to IS cos of minus so this is equation 2. Now put equation 1 in equation 2. So I is equal to IS cos of 10 minus I Z0 tan of into 10 divided by Z0. Now here L is 10, which is given. Therefore I is equal to IS cos of 10 minus I is sine by divided by cos into, so we solve this equation again. Divided by cos n. So I is equal to I is cos divided by cos, but it is equal to 1. So we substitute this one in above equation. So the equation is I is equal to Is by cos of A, but we have Is is equal to 20 milliampere, that is equal to milli is 20 into 10 raised to minus 3 ampere. Gamma is equal to alpha plus j beta, so it is 0.1 plus j 0.04. Therefore I is equal to 20 into 10 raised to minus 3 divided by cos of 0.1 plus j 0.04 into 10. So this is 20 into 10 raised to minus 3 divided by cos of 1 plus j 0.4. So it is 20 into 10 raised to minus 3 divided by cos of 1 cos plus j sine of now here we use the calculator in radian mode. Therefore I is equal to 20 into 10 raised to minus 3 divided by 1.42 into j 0.45, that is equal to 20 into 10 raised to minus 3. In angle it is it is 1.49 angle 0.306, so it is 0.013 angle minus of 0.306 radian, and in it is 0.013 in ampere. It is thus received current in 13.42 milliampere in magnitude and lags the sending current by 17.58. It is 13.42. Calculate the characteristic impedance, attenuation constant and phase constant of transmission line of following measurement which have been made on the line. ZOC is 550 angle minus 60 degree, ZSC that is short circuited is 600 angle minus 14 degree ohm. So first is calculation of characteristic impedance. First calculate characteristic impedance, that is Z0. We have Z0 is equal to square root of ZOC, that is short circuit, open circuited and short circuited. So we have both these value. It is 550 angle minus 60 degree and 500 angle minus 14 degree. So it is 275,000 angle minus 74 degree. It is in square root. Out of square root it is 524.404 angle minus 37 degree. So in the form of J, it is 418.8 minus J 315.59 ohm. Second part is calculate attenuation constant as phase constant. Calculate attenuation constant and phase constant, that is alpha and beta. So first we calculate the propagation constant, that is gamma. We have the equation of open circuit impedance. ZOC is equal to Z0 cot of H gamma L. This is equation 1. Now it can be written in the propagation constant per unit length as it is equal to Z0 1 by tan H of gamma. This is per unit length, but Z0 is equal to square root of Z open circuited into short circuited. So ZOC is equal to, we substitute this value in above equation. It is ZOC ZSC into 1 by tan of, therefore tan of is equal to square root of ZSC divided by ZOC. This is equation 3. Now equation 3 gives the propagation constant in terms of ZOC and ZSC. Therefore tan of, it is 500 angle minus 14 degree divided by 550 angle minus 60 degrees. So its value is 0.909 angle 46 degree. So this is in square root, so it is value is 23 degree, and in the form of J it is 0.877 plus J 0.372. This is equation 4. Now to solve the equation 4, we use the mathematical identity. So tan H of is equal to tan H of alpha plus J beta, because gamma is equal to alpha plus J beta. Since we write here gamma is equal to alpha plus J beta. This is equation 5. Now consider tan of H alpha is equal to tan of alpha plus J beta is equal to U plus J V1 equation we have considered here, and so we can write alpha is equal to 1 by 2 tan inverse of 2U by 1 plus U square plus V square, and beta is equal to 1 by 2 tan inverse of 2U by 1 minus U square minus V square. Now comparing equation 4 and 6. Compare equation 4 and 6. So U is equal to 0.877 and V is 0.372. Therefore alpha is equal to tan inverse of, substitute these values here, 877 1 plus 0.877 square plus 0.372 square. Therefore alpha is equal to 0.7929 per kilometer, and beta is equal to 1 by 2 tan inverse of 2 into 0.877 divided by 1 minus 0.877 square minus 0.372 square. Therefore beta is equal to 0.7590 radian per kilometer. The unit of beta is radian per kilometer, so the calculations of the beta is in radian mode here. Okay, thank you.